Okay, so look at question number 1. The diagram show the line y equals to 1 plus 2x, 1 minus 2x, intersect with your curve y equals to x cubed at the point P. Then by taking suitable first approximation x naught, use Newton-Raphson method to find the point P in 3 decimal place. So they want this. What is your point P? Means they want to find what is your x. So when you want to find intersection point, you need to solve 2 simultaneous equations. So the first equation comes from your line y equals to 1 minus 2x. And then second equation comes to your curve y equals to x cubed. Substitute both equations, you can form x cubed equals to 1 minus 2x. So this is your non-linear equation. And then Newton-Raphson method can use to solve non-linear equation. So before we can get this equation, we have to make it equals to 0 as a function. So this equation x cubed will be plus 2x minus 1 equals to 0 become function. Then by Newton-Raphson method, you need differential function. So we differentiate this x cubed. We differentiate, we get 3x squared. Then 2x, we get 2. Differentiate constant, we get 0. So what can we observe here? What is our first approximation from graphical method? So normally we have 2 methods. One is algebraic method, one is graphical method. Algebraic method, they give us interval, we substitute value, we analyze positive, negative. So we can get the first approximate value. So from this question, they ask in graphical method. They draw out the graph for you. You can see your point P is 4 in between 0 and 1. So from here, from graphical method, that we can see our x naught can take the value in between 0 and 1. So we can start from 0.5 as long as your initial value start in between 0 and 1 because we see one intersection point in the interval 0 and 1. So by identifying your first approximation value, we can start our Newton-Raphson method where the formula will be x1 equals to 0.5 minus function, which is your x cubed plus 2x minus 1 over differential function 3x squared plus 2. So revise here, Newton-Raphson method, xn plus 1 equals to xn minus fxn over differential function by substitute your x value. Then we use our calculator to find out what is your second approximation value. Alright, so key in your formula. Initial value 0.5, you substitute, we get fraction, but in Newton-Raphson method is a numeracy method, so we want in decimal. But in your decimal, final answer only give 3 decimal place. Meanwhile, in working, we will plus 1 or 2 more decimal to avoid routing error. Alright, so we make it decimal. This is 0.454, and then we add 1 2, it will become 5. So for this new approximate value, we continue for second step. So if you want to write the working in full, also can. Then calculate, key in your decimal. $398. So it becomes 40. And then continue until we get repeated x. So 397. Round off 34. So this one already repeat. Therefore, we can come up to the conclusion where solution for this equation x will be equals to in 3 decimal 0.453. So what do you need to find out is not only the x coordinate from this non-linear equation, is the point, means including your point y coordinate. So after finding your x coordinate, we substitute into either one equation. Let's say into equation 2 to find y coordinate. So 0.9295. When you want to round off, it will become 30. Okay, so write your point coordinate in coordinate form.